In this tutorial, we will learn how to compute turnover rates using R. Turnover rates are a specific type of human resource metric, or HR metric for short. So to get started, we have a toy data file here called turnover_rate with a lowercase t and a lowercase r for turnover and rate respectively. This is a comma separated values file, and that can be shortened as a .csv file. So be sure to save this file into a folder that we will subsequently refer to and set as our working directory. Now note here that we have three variables we're going to be working with today. This is a very small data file here, and this is just to represent 1 year's worth of turnover data, where we have turnover collected and documented every month of the year, where you could say that month 1 is January and month 12 is December. Note that we have a variable called separations, and this is the total number of separations, and specifically employee separations for each month, where a separation can refer to voluntary turnover, involuntary turnover, or both types of, or all types of turnover. In this case, let's assume that separations refers to all types of turnover, whether it's involuntary or voluntary. Now notice that the third variable here is called av_employees, and this refers to the average number of employees who are working here in this particular unit or organization in a given month, where let's assume that the average number of employees was calculated behind the scenes by taking the number of employees working for this organization on the first day of the month and adding that to the number of employees who were working for the organization on the last day of the month, and then divided by 2 to calculate the average. All right, so again, make sure you've saved this file or whatever file you're working with, that's a .csv format, again, that's comma separated values format, into a folder that you can subsequently set as your working directory. And so now we are ready to get into R. And so as you can see here, we've got the RStudio console open. You can see we have some intro text here that gives us some R version history. Let's go ahead and clear that out to keep things tidy. So you can go to Edit, Clear Console. The next thing that we're going to do is go to File, New File, and R Script. That's File, New File, R Script to open up an R Script editor window. This will allow us to keep track of the code we write, as well as to include annotations to explain what we're doing and any kind of major decision that we might be making. This is useful if you're collaborating with other people, or just to remind yourself at a future date what you were doing in a given session. So using the hashtag annotation feature, which means that anything that I type to the right of a hashtag or the pound sign will be treated as an annotation by R, which means that it won't be treated as a command. So I'll start off by just making a note here at the top what the focus of this tutorial is today, which is computing turnover rates using R. And I'll make a note below this that this will include both monthly turnover rates and annual turnover rate. So the first thing that we're going to do, which I mentioned earlier, is we need to set our working directory, and we're going to set it to be the folder where that file is that we saved. Now I have saved it into this folder. You can see here is the file name, turnover_rate is a comma separated values file, or .csv. I've saved it into my H drive, and within the H drive, my R workshop folder. Almost certainly you're going to have a different pathway and folder at the end of that pathway where you're saving this file. So just make sure that you locate the appropriate one. And so to set the working directory here, I'm going to use the setwd function, which is setwd all lowercase. And within the parentheses and within quotation marks within those parentheses, I'm going to type in the exact name of my path here, where that H drive and R workshop folder and the data file lives within that. So it again is my H drive, R workshop, which is where I happen to be storing this file or saving that file I'm going to be working here with today. Now you could alternatively go to Session, Set Working Directory, and Choose Directory to do this through drop downs. This is another way of going about setting your working directory, and if you do that, you'll get the function will be input into your console here, or rather it'll be output in your console, and then you can copy and paste it. So for example, this is what it'll look like, whether you do this by writing the code directly or by using the drop-down menus of going Session, Set Working Directory, and Choose Directory. It'll appear in your console, and you can always copy it and then just paste it into your script. And so that way you can quickly access this working directory and set it in future sessions after you've closed down RStudio and then you open it back up again, for example. All right, so I've already run this line here and I'll just run it again. Just to show you again, we get blue text down here, which is usually a good sign in our console. And you can see here in our console window, it notes that I have set my working directory to be my HDrive R Workshop folder. The next thing I'm going to do, I'm making a note here, is read in the data file. And remember that data file is called turnover_rate, and it is all lowercase. And so to read it in, one of the first things that we'll do is we need to come up with a name for the object that we're going to assign this data frame to when we read it in. So I'm going to call this data frame object TR, all lowercase there, to stand for turnover rate. You can name it whatever you'd like. And so to the right of this object name that I've selected there or specified, I'm using the left-handed arrow operator so that I can assign anything that comes to the right of this arrow to this object. All right, so I'm going to use the read.csv function from base R, that's read.csv all lowercase, in order to read in that data file. And so within the parentheses for the read.csv function, type quotation marks, and within those quotation marks, type the exact name of the file. To get the exact name of the file, I'm actually going to go here and just click on it, copy the exact name of the file that I saved to this working directory here, paste the name here, and then I'm going to make sure that I add the .csv extension, where again, CSV stands for comma separated values. You need to have this .csv extension included after your exact file name when you're using the read.csv function, and so be sure that you include that. All right, so now I'm going to put my cursor anywhere on the line or highlight the whole line and click Run. And now you can see that in my global environment, I have a new object. It's called lowercase tr here. It has 12 observations, where in this case, each observation corresponds to a month of the year. And we have 12 months in the given year of data we have access to. And there are 3 variables, which I already reviewed a second ago, and we'll see those again in a moment. So I can view the data doing one of 2 things, or there's other ways to do this, but I can click here on the name of the data frame object, and it can pop up here in the viewer window. And as you can see, here are the 3 variables and the 12 observations. So month, separations, average number of employees per month. And the other way that we could go about viewing the data, among others, is to print the object to the console. Given that this is such a small amount of data, we can actually view this in our console relatively easily. And so I'll use the print function here, which is from base R, which means we don't need a special package that we need to install in order to access this function. It comes standard with base R. And so this is print all lowercase, and as a sole parenthetical argument, I'm going to copy and paste in the exact name of the object that I assigned this data frame to, that I read in. So I'm going to run this, and you can see down in my console, this is again another way of viewing that same data frame object. Okay, so now that we've seen this, the next thing that we're going to do is compute the monthly turnover rates. And I'll show you a few different ways that you can view this and follow through with this process. And we'll start with the simplest way, which is that we are going to be taking first the name of the data frame and typing that in, which is lowercase tr, followed by the $sign, and this will allow us to attach a specific variable from that data frame to this $sign. So it's a way of referencing a particular variable from a data frame, and so that R knows where that data frame or where that variable comes from. All right, so the first thing that we're going to do is we're going to find the variable that represents the total number of separations in terms of employees who have left the organization, in this case either voluntarily or involuntarily, in a given month. And so I'm selecting separations. Remember, R is case and space sensitive when it comes to variable names and object names, and so you can see here that it is a capital S for separations. So we want to make sure that that is correct and correctly specified. The next thing I'm going to do, this is just a simple division that I'm going to be doing here, is I'm going to use the division symbol or the division operator here, which is just a / using the R language here. All right, the next thing I'm going to do is divide the total number of separations by the average number of employees in a given month. And so to do that, I will type in the name of the data frame object again, $, followed by the exact name of the variable that contains the average number of employees that are working for the organization or did work for the organization in a given month. So as you can see here, we have a simple fraction here, or division equation, where we take the total number of separations and divide it by the average number of employees per month. Now, there's other ways that we can compute turnover rates, and there's different ideas in terms of how specific you want to be in terms of, and it's really based on your organization's needs and what you're trying to understand. Here, we're being very vague in terms of what the separations are. They could be either involuntary or voluntary forms of turnover. And also, when it comes to calculating what the average number of employees is per month, there's different thoughts on that as well. We're taking a very simple approach here, which again is just the total number of separations per month divided by the average number of employees who are working in the organization per month. And if we run this line right here by highlighting it or putting our cursor somewhere on the line and clicking the run button, we will actually get a vector as output here in our console that gives us the monthly turnover rate as proportions. Okay, so I'll make a note here that this is as proportions that we're generating here. So you can see here, this goes sequentially from months, in this case, because it's months 1 through 12 sequentially, so too are these turnover rates for the monthly turnover rates. And you can see the first month we have a turnover rate of about 9%, or in other words, a proportion of 0.09. Second month, which would be February, in this example, we have a turnover rate of about 0.08 or 8%, and so on and so forth through the 12th month, which is December in this case. Okay, so that's how we can compute the monthly turnover rates as proportions. Now, what if you'd like to compute them as percentages? Well, to do that, I will copy and paste these exact two lines that we just wrote there. And I'll change the annotation here to just note that we're going to be doing percentages now. So we're going to compute the monthly turnover rates as percentages. And to do so, we are going to just use the multiplication operator here, which is the asterisk, and multiply this line by 100. Now you could put the 100 times 100 behind the fraction that you did here, or you could put it in front. It really doesn't matter. You could put quotation marks around the fraction, which represents the actual turnover rate metric when we compute it as a proportion, but you don't need that because due to mathematical orders of operation here, when you have division and multiplication, you can put them in any order in this case, okay, without the need for parentheses. All right, so I will keep things simple here and remove the parentheses and just multiply this by 100 and watch what happens here. So down in our console, now we see that these proportions have each been multiplied by 100. So what this is doing is multiplying each value that's in our vector, our original vector here, which we see printed right here, by 100. So any proportion times 100 is a way to convert it to a percentage. And so here you can see that now we have this in percentage notation. So 9.45% monthly turnover in January, for example, and 2.36% monthly turnover rate in December, which is the 12th month here. All right, so we can also go a step further and we can actually assign either one of these as proportion or as percentage, and let's just go ahead and assign the monthly turnover rates as percentages to a variable that we can add to this turnover rate or TR, lowercase tr data frame object we created. So we'll add another variable here to the right of the average number of employees, and let's call that variable, and actually before I do this, I'll make a note that we are going to be adding the monthly turnover rate variable to the data frame object. And so to do that, we are going to copy this code right here that we just wrote to compute the monthly turnover rates as percentages, paste it down below, and then to the left of it, we're going to use that left-handed arrow operator, the same one that we used earlier to read in the data and assign it to an object that we could subsequently reference. And now to the left of this left-handed arrow operator, we are going to state first the name of our data frame object so that R knows where the variable we're going to create is going to be attached, and then come up with some name for this new variable. So I'll call this uppercase TR underscore monthly with a capital M for monthly. You can name this variable whatever you'd like, so long as it doesn't start with a numeral or a special symbol such as the dash. All right, so as you can see here, we are assigning this formula here, or the result of this formula here, which will be this vector, or the values that you see here in this vector, using the left-handed arrow operator to this variable that belongs to this data frame object. And again, we're using the dollar operator here, dollar sign operator, to note that this variable belongs to this data frame object. So go ahead and run that line there. You'll see we get blue font down here below, and because we created an object, we don't get the output here in our console of what that object contains. And to view it, we can just go up here. We happen to already have our viewer window open. Alternatively, you could click here, or you could go to and print this directly by just printing that data frame object using the lowercase print function there with the name of the data frame object as a sole parenthetical argument, and run that. And now you'll see we do have that fourth variable, which is named what we named it, capital TR underscore capital M, and then the rest of monthly there. And so now you can see the values are a new column or variable in this data frame object, and it's easier to see that month one's monthly turnover rate is this value, month six's is this value, and so forth and so on. So we again have taken that that equation that we created to compute the monthly turnover rates as percentages, and now we've assigned it as a variable that's attached to our data frame object. Okay, now as an optional additional foray, so this is optional data visualization. You don't need to do this, but this is something, if you're interested in this is a quick and easy thing we can do with a simple function that comes standard in base R, which is called the plot function. That's lowercase plot, P-L-O-T, P-L-O-T. And we can just take the two variables and the data frames that they're from and plug those in as two arguments, and we can create a very simple rudimentary line graph if we'd like. So how do we do that? Well, to do that, we can start off, and the default won't actually be a line graph, it'll be a scatter plot, but nonetheless, with a few extra steps, we can actually create a line graph without too much trouble. Line graphs are also referred to as line charts sometimes, and they are a specific type of data visualization. So the first thing we'll do is enter the x equals argument and the name. Let's make the x-axis, so this is why we're using the x equals argument for this function. We'll make sure that the x-axis is the months, so months 1 through 12, which correspond to January through December in a given year. And so we'll do x equals the name of the data frame object, dollar sign operator, and then the exact name of the month variable, which is month with a capital M. Okay, so that's the x-axis. Let's use a comma there to separate the first argument from the second argument. Second argument is y equals for the y-axis, and we need to specify the variable that will be designated as our y variable. And so that is going to be, again, starting with the name of the data frame object, dollar sign, and then this is going to be our new monthly turnover rate, or TR underscore monthly variable we just created. Type that in there and click run. And now you'll see in our plots window here that you can see we get a scatter plot here. So again, by default, it is not a line graph, but to make this into a line graph, it's relatively simple. But you can start to see the trend here, if there is any trend, in the viewer window. And if you want to export any one of these plots that you create, just go to the export tab here and either save it as an image, and specifically a PNG image, or as a PDF if you'd like to do that, or you can copy it to a clipboard and just copy and paste it into another document of some kind. All right, so how do we make this into a line graph? Well, to do so, we can add a third argument, which I'll actually add another comma, and then I'll return down to another row. You don't need to go to the next row here, but sometimes it's easier to read. And so if we do the type equals argument, this will specify the type of graph. And so if you'd like a line graph, just do quotation marks, and within the quotation marks, just type in a lowercase l. So again, that's lowercase l there in case you're curious what that character is. And then let's run that. Okay, so as you can see, we have updated this plot with it. So it went from scatter plot to line plot. And so now you can see the shape of the monthly turnover rate trend over a given year rather. And so here's January all the way to December in this fictitious example here. Now, what if you'd like to make more meaningful axis labels here, so axis labels here? So here on the x-axis, we have, this is just the code here, as you can see, for the data frame and the month variable. But what if we want to make it more meaningful there? Well, we can just use the xlab for x-axis label equals argument here. Again, that's xlab equals, and then type in quotation marks, and anything you include in quotation marks here will appear as the month down here. And so I'm just going to clarify that this, let's just call this simply month here. That's what the new label will be here for the x-axis. And then let's add another argument, and that's ylab equals. And so this is, we can update the y-axis label here. And so let's make the y-axis label, and let's make sure we put in the quotation marks there. Let's just call it monthly turnover rate. And I'll note in parentheses here that it's a percent, just so that people are clear. That's what we're referencing here. Okay, and then click run. So as you can see, we updated those two axis labels there. All right, so you could look through here and then try to discern whether or not you see any kind of trend or pattern. As you can see, the monthly turnover rates fell from about January to May, and then they started increasing for a couple of months, dropped again, and then increased steeply, kind of plateaued, and then started tailing off again towards the end of the year. So descriptively is one way we can go about trying to understand turnover rate. It's just by comparing monthly turnover rates to previous turnover rates, monthly turnover rates within a given year or even across years. So speaking of across years, and one other thing I want to show you too is what if you want to adjust the y-axis limits. So in this case, if you want to maybe extend them a little bit, make this plot, scale it differently, in other words, you can add another argument, which is ylim equals for the y-axis limits. And we'll use the C function from base R, which you can think of as being combined. This is how we can combine either values together in order to create some kind of vector. And so we'll just input two numerals here, or two numbers. And the first one is going to be what we want the lower limit of our y-axis to be. In this case, I'll make it 0, which is what it is already. This is the 0 point here by default. And then add comma to separate this argument from the second argument here. The second argument, or the second value in our vector here more specifically, is whatever we'd like to set the upper limit of the y-axis to be. In this case, it looks like it's about at 10. Let's increase that to 25 just for the sake of explanation and demonstration. Click run there, and now you see we've scaled it differently here. And so this is not a decision to be made lightly in practice in terms of how to scale a y-axis. You want to make sure that however you do it is going to fit with whatever your conclusion is going to be. And of course, you don't want to mislead people or overstate or understate things intentionally. All right, so the next thing that we're going to do is we are going to shift gears and compute the annual turnover rate. Okay, so we've been focusing on monthly turnover rates within a year. Now we're going to switch gears and compute the annual turnover rates. So before we were working across rows here. So for each month, when we wrote that formula before, we were taking the total number of separations for each month and dividing it by the average number of employees for that month. We're going to be working across columns here when we're doing annual turnover, and I'll show you what I mean by that. And so what we're going to be doing is our numerator in the equation we're about to write, or in the fraction we're about to write, is going to be the total number of separations for a given year across all these months in this case. So we're going to be summing up the values of this whole column here. Okay, so the total number of separations, and we're going to be dividing that by the average number of employees per month. So it sounds a little funny to say it that way, but we're going to take the average of these values that fall in this column here. So trying to find the average size of essentially the organization in terms of headcount or number of employees for the entire year. And so that's how we're going to compute the annual turnover rate as a proportion. And so we'll start with what's called the sum function from base R. This is going to be creating our numerator here in our fraction or metric that we're creating. Okay, so the sum function is sum all lowercase. As the first argument in the sum function, we're going to include the separations variable here because we want to take the sum of this whole column here. And so just as we were doing before, type the exact name of the data frame object, which is in this case tr lowercase, and then $ operator followed by the exact name of the separations variable, which is separations with a capital S for separations. And then comma to separate this first argument here from our second argument, which is we don't need it here because we don't have missing data, but I recommend getting in the habit of including this with the sum and the mean functions, which is na.rm equals true. So na.rm equals true means NA is the designation for missing data. So if you were to see NA, capital NA in any of these cells here, that would mean that there's missing values there. RM stands for remove. So what is it saying to do here? It's a logical statement. So it's saying remove missing values essentially, or missing data before calculating the sum. So just keep this in exactly as it is. And I recommend doing this both for the sum and the mean functions, and I'll be showing you that in just a second. So to do the mean function, let's just go ahead and get a head start here by copying this chunk that we just wrote there, adding our division symbol because this chunk we just copied is our numerator in this fraction that will help us compute this metric. As our denominator, go ahead and paste in what we just copied there. And instead of the sum function, we'll type in mean. In other words, mean for average. And this is MEAN, all lowercase. And we're just going to swap out this variable, the separations variable, with the average underscore employees, or av underscore employees variable. So av underscore employees. So that's capital A for av and capital E for employees, and make sure there's an underscore between. And we can leave the second argument as is because we're instructing it to calculate this by removing any missing data if there are any missing data. So that's what that logical statement means again there. So just with this simple equation here, we can compute the annual turnover rate as a proportion. And so you can see the average or the annual turnover rate for this particular organization or this unit, whatever we're focusing on here is the unit of analysis, is a proportion of 0.52, which you convert that mentally to a percentage, is about 52% annual turnover rate. Okay, so let's do what we did above here with the monthly turnover rate by copying these two lines. So then we can convert the annual turnover rate from a proportion to a percentage. And it's going to be really simple. All we do is the same thing as we did before, which is just we multiply this fraction here, or this first part of our equation, by 100. So we're using the asterisk here and then multiplying by 100. Click run. And now you can see we have just printed it to our console like we did before with the proportion, but now it's converted to a percentage. So this is 52.4% or so. All right, so the last thing we can do, if we'd like to, we don't really need to do this, but if you want to reference your annual turnover rate subsequently as an object, like include it in other functions or other equations, sometimes it's easier to assign your annual turnover rate to a particular object. And so let's go ahead and do that. Copy these two lines here for our most recent code, and then I'm just going to say assign the annual turnover rate as a percentage to a vector object here. So we're just going to assign it to a vector object. All right, so the way that we do that is by putting the left-handed arrow operator to the left of this equation that we wrote out here above. So it's the annual turnover rate as a percentage equation. And then to the left of the left-handed arrow operator, just type in the name of some object that we'd like to assign this to. So this is an object that doesn't yet exist. We're not going to be overwriting any existing objects. So let's call this tr, capital T, capital R, underscore annual with a capital A for annual there. Okay, so we can assign this to what will become a vector object here. And so let's run that. And so now you can see here we have a vector object there. If we'd like to print it to our console and view it there, we can just use the print function like we did before, and the exact name of the object, vector object that we just reference there, or we just assign this the result of this equation to. And so now you see that appears in the parentheses within this function. Click run. And so now we've printed it to our console. Now, if you'd like to, and this is just maybe for special circumstances where you ultimately want to combine perhaps these annual turnover rates together in a data frame object or something like that, one way you could do is if you want the annual turnover rates to be separate columns, for example, you could convert using the as.dataframe. This is completely optional. I'll make a note here. So optional, convert vector, and this goes for any vector, to a data frame. You can use the as.data.frame function from base R and just type in, or copy and paste in, the exact name of the vector you'd like to convert to a data frame. And then to the left of this, use the left-handed arrow operator to assign the result of this to a different object. And so I'll just call this temp, T-E-M-P, for temporary, just for an example here. And so click run. And so now instead of being a value vector here, we see that it's its own data frame in our global environment here. If we click on temp, we can see it's a very small data frame here where it has one row and one column. Again, this is just, there's different ways you could do this. You could also combine using the C function different objects that have annual turnover rates together if you want to create a longer vector that has multiple annual turnover rates, for example. All right, so this is how you can compute turnover rates using R, and I showed you how to do both monthly and annual turnover rates using simple formulas. Now, note that, again, I mentioned this earlier, that there are different ways that people might go about computing monthly turnover rates and annual turnover rates, and they have different assumptions. I just showed you a very simple way of doing it, but please note that there are different ways that you can do this, and there's textbooks, and you can look at this up online. There's different opinions and different situations in which you might prefer one formula over the other, but this will work just fine for our purposes. Thank you very much.